Hello everyone, and welcome to Algebra 2. Today is the first day of Chapter 5, and we're going to be doing Section 5.1, nth roots and rational exponents. So if we were in class, I would not normally actually start teaching. I would have you work with a partner, as you can see, and study these following statements to see if you can write a general rule. So I do hope that you'll pause the video and look at these 6 statements and see if you can figure out what the general rule is. So of course I will tell you that if you have the nth root of a, another way to write that is a to the 1 over n. So today we're going to expand that rule a little bit, and you might have the nth root of a, but then a has its own power. If this happens, then you could rewrite it as the nth root of a and then take the whole thing to the m, or if you want to put it as a fractional exponent, a to the m over n. The key is to realize that in either case, if n is the root, that's what goes in the denominator. So if a doesn't have an exponent, which would mean by default it's 1, then it would be 1 over n. But if there's an exponent there, it's still an exponent. But the radical portion is always the denominator of the exponent. So let's use that expanded power rule to do these next few problems. Again, you should really try them on your own without me, and then look to see if you get the answers right. So there's 2 ways to write letter A. You could do the cube root of 8. Remember, the denominator is always the root, and then square it, or you could write it as the cube root of 8 squared. Either one will give you the same answer. In this case, you can simplify because the cube root of 8 is 2, and then 2 squared is 4. So this one actually simplifies. They're not all going to simplify. But even if you had done it this way, 8 squared is 64, and the cube root of 64 is 4. Letter B. Remember, the denominator is always the root. So it's a square root of 6 to the 5th. But whenever we have a square root, people tend not to write it. So you can write it as the square root without the little 2 of 6 to the 5th, or you can write it as the square root of 6 and then the whole thing to the 5th. Both answers are perfectly acceptable. Letter C is going to be the 4th root of 12 to the 3rd. Personally, this is how I write it because my chances of being able to find the 4th root are better in the smaller version, but it is still acceptable if you wrote it as 12 to the 3rd. All right, if you are watching this completely and not pausing, you're making a mistake. You really should try to do these next couple on your own. This is the square root of 10 to the 3rd, or the square root of 10 to the 3rd. Now that one does simplify it a little bit. Since you have the square root of 10 3 times, it would not be unacceptable to write it as 10 square roots of 10. So there's lots of different ways to write the answer. But in this case, we're really just trying to practice this skill right here. Square root of 16 to the 3rd. Square root of 16 to the 3rd. Again, you don't have to write the little 2, which is 4 to the 3rd, which is 64. Again, if you had chosen to do square root of 16 cubed, this is a good example of where it would have been much harder to do the cube first. You probably wouldn't have recognized whatever number that is as a perfect square. So I personally do the root and then the power. And the last one, this is 20, and then the root is the 5, and the power is the 6. So the denominator is the root, and the power stays a power. All right, let's go in the opposite direction this time. If you need to, you can put a little 2 in there when there's not one there. an exponent stays an exponent and a radical becomes the denominator in the exponent. This is going to be 4 to the 2/4. And when you can reduce, you should. 4 to the 1/2. Ooh, and then I know 4 to the 1/2. That means square root of 4, and square root of 4 is 2. So when it simplifies, you should do that. The next one is 9 to the 2/3. The next one is 10 to the 4/5. 15, again, if it helps you, you can write a little 2 in there, to the 3/2. And the last one, 27 to the 4/3. Although this one you can simplify, the cube root of 27 is 3, and 3 to the 4th is 81. So sometimes when you don't see your answer the way you think it is, it's maybe because you could have simplified it. So this concept right here of being able to go from fractional exponents to radical notation or radical notation to fractional exponents is the key. Real nth roots of a. So there's a little chart here to help you, but I'm going to give you a little example for each one. If n is an even integer, then if a is a negative number, so for example, if you're doing the square root, which means I don't have to write the little 2, of a negative number, we know that that produces an I. There are no real roots. If a is just 0, then there's exactly one real root, because no matter what it is, whether it's a squared or a 4, the square root of 0 is 0. But if a is greater than 0, so positive 4, then there's 2 n roots. So plus or minus 2. If n is an odd integer, then something like 3, the cube root of 8, which we could write as 8 to the 1/3, is going to have one real root. In this case, it's 2. Of course, cube root of 0 or fifth root of 0 or anything is always just going to be 0, so that has one real root. But here's the big difference between these two, and that is if n is an odd integer, you actually can take the root of a negative number. Because remember, what cube root means is you're pretty much saying what number, when multiplied 3 times, makes -8. And since -2 times -2 is positive, but then times another negative is negative again, there is an answer there. Just one, but one real root. So let's do some examples of these. Find the indicated real nth root of a. So in other words, you need something that when you multiply it 4 times by itself, it's going to give you 16. So what times what times what times what is equal to 16? Well, that number could be 2 or -2, which of course you can write as plus or minus 2, because just like 4 positives would obviously make a positive, 4 negatives would also make a positive, so there's 2 answers. What 2 identical numbers would make -49? That's never going to happen. So there are no real roots. Of course, we know that we could use an imaginary number I, but there's no real roots. This means to have a root means what root could I multiply by itself 3 times to get -125? And the answer is -5. You can see if you can do the last 3 on your own, but of course I will do them for you. So we're looking for something raised to the 5th power instead of multiplying it out 5 times. That would give us 243, and that root is 3. We're looking for a number that when it's raised to the 3rd power is equal to -216. And when you raise -6, not +6, that would give you +216. So remember that with odd numbers, there's an answer whether or not it's odd or even. And now I'm looking for something to the fourth power that will give me 81. And that number is 3. 3 to the fourth is 81. What about negative 3? Oh yeah, see, that works too. So when this is even, there's 2 possible answers. But when it's odd, there's only going to be 1 possible answer. All right, so I know this is a little funny how I wrote it, but here's why. I did not want to use the notation, the fourth root of 16. Okay, I really need you to pay attention to this because this is important to me. The fourth root of 16 is not equal to plus or minus 2. If I ask you what the root, the fourth root of 16 is, then you can say plus or minus 2. But once you have this notation in here, that means somebody has already decided that it's plus. So if somebody ever says to you, what's the square root of 4? Don't say, oh, it's plus or minus the square root of 2. Once that square root is there, it's already been decided that it's the plus. If somebody goes like this, then that means they want the negative square root of 4, which would be negative 2. Here's how you get the 2 different roots. When you say, kind of like we were doing here, something squared is equal to 49. Then when you put the square root in, you also put the plus or minus in because you're saying, I know that there's 2 roots. I know there's 2 things here that could make 49. They are plus or minus 7. But a lot of times after we do this section, kids will see this on their homework and they'll write plus or minus 5, which is wrong. It's just the square root of 25 is just 5. It's when you put the radical in that you also put the plus or minus in. And that's why I wrote it this funny way instead of writing this as the fourth root of 81, because I wanted you to say plus or minus 3, but this is just 3. Little bit of a notation thing here, but it is important, and I'll have to talk about it again and again, and that's okay. So here's the rule that we just went over. And now we're going to add a second one, a to the negative m over n. So this is actually a rule that you're already familiar with. X to the negative 3, we did this with just regular integers, is the same as 1 over x to the 3. Now we're going to do that exact same process, but with fractional exponents. So 16 to the 3 halves, let's see if we can simplify that. I'm going to make it a square root of 16 and then cubed. Remember, you could have put the cube on the inside, but it would have made it a lot harder. Square root of 16 is 4, and 4 cubed is 64. But if the exponent is negative, then your first step should be to move it to the bottom. And now it's positive. And then you can change it to a format that maybe makes more sense. So the fifth root of 32 and then cubed. Always keep that in mind. A cubed is always a cubed. But if there's a denominator, it indicates that you have a root. The fifth root of 32 is 2, and 2 cubed is 8. You should really try the next 4 on your own, but of course I am going to do them for you. So this is the square root of 4. The denominator indicates a root to the 5th power, which is 2 to the 5th power, which is 32. Number 4, I see a negative exponent, so my first step is to move it to the bottom and make it positive. Now some of you might start to recognize this. Oh, 9 to the 1/2. That's the same as a square root. You do not have to show the next step if you can look at a 1/2 and think square root. But in case you can't, I'm going to show you that step. And the answer is 1/3. 81 to the 3/4 is the same as the fourth root of 81 to the 3rd. The fourth root of 81 is 3. So now I have 3 to the 3rd, which is 27. And 1 I'm not even going to worry about. 1 to the any power is always 1 because it means 1 times 1 times 1. So 1 times 1 times 1 times 1. Any number of times is always 1. And similarly, the square root of 1 is 1, or the cube root of 1, or the fifth root of 1, or anything. So when you see 1 to the any power, 1 to the n is always 1. Keep that in mind. So these next three, you're going to evaluate on your calculator. The first one is 9 to the 1/2. So I'm going to hit the 9. Here's the to the, and you can literally just type in 1/2 and hit enter, and the answer is 3. Then our next one is 12 to the, this used to be a little bit more complicated because the calculator didn't keep the next number as part of the fraction, but the calculators have improved over time, and this is pretty straightforward. But you do have to decide how you want to do number 9. Personally, I love fractional exponents. I would definitely change it to 7 to the 3/4. But I am going to show you how to do a radical on your calculator. So if you go to math and you go down to number 5, then look, it'll make that for you. So 4, and then you can put the 7, and then after, make sure you use the arrow to get over. After, now you can say to the 3rd. You don't need the parentheses. It will do the entire thing to the 3rd. And you get 4.3053. So you can see it's the same answer either way you did it. I personally think that that's a lot more work, which is a great reason for knowing fractional exponents. Before we do this next section, I want to show you a little chart that I made that you might want to screenshot and put into your appendix. And that is a chart of all the, not all, but a lot of the perfect squares, perfect cubes, numbers to the 4th power, 5th power, 6th power, 7th power. I don't really have all of these memorized, but I have a good number of them recognizable, meaning we're about to do problems where it might say x cubed is equal to 216. And if you kind of have that number in your head as being something that you might be a perfect cube, that would be helpful for you then to say, oh, that is a perfect cube. X is equal to 6. So you probably know most of the perfect squares. When you see 49, you know that that's a perfect square. But here's the cubes. I wouldn't expect you to know any higher than that. And notice the list keeps getting shorter. I wouldn't expect you to know 8 to the 5th. But definitely, well, 1 to the 5th, 2 to the 5th, even 3 to the 5th. Just some of these numbers need to be things that you know. So I thought you might want that chart. So our first one, we're going to divide both sides by 4. This is something that you're very familiar with, which is isolating the exponent before you continue working. So this is 32, and then this is why I gave you the chart. 32 needs to be in your head as something that's recognizable. You look on your chart, oops, wrong way, and x is equal to 2. Is it plus or minus 2? No, it's to a 5th power. 5th powers, any odd power is always going to have just one answer. Number 3, you always want to isolate this portion of it, this u to the n, divided by 8, and I get x cubed is equal to 8. That is a perfect cubed. It's odd, so there's only one answer, and x is equal to 2. Oh, I guess my 3 and my 4, oh, they're down there. Okay, now be careful here. This is already considered of the form u to the n is equal to d. You cannot take that 3 out. It is stuck in the parentheses. The entire thing is being raised to the 4th. So it's at this point that you are going to take the 4th root of both sides. So I get x minus 3 is equal to the 4th root of 21. This is an even power, so I have to remember to write plus or minus. 21 is not on my list, so I know that I can just stop there. And then I have to add 3 to get the x all by itself. Now, you could write, some people just tack it onto the end, but then you take the risk of writing 4th root of 24, which I've seen lots of kids do, and this would be wrong. That 3 is not part of the 4th root, so you're better off writing it out in front, 3 plus or minus the 4th root of 21. On number 5, we're going to clear our fraction first, and that gives me x to the 5th is equal to 1024. Hopefully that's a vaguely familiar number. It is on our list, and it is a 5th power. It is, so this is 4 to the 5th. So I can go back, and if you want, you can actually do this step where you write to the 1/5, to the 1/5, or you have x to the 5th is equal to 1024. You can do 5th root of both sides. Either notation is good, but when it's a perfect root like that, you could just write 4. Just jump straight to the answer. Great. Okay, this is another one where this is already in the form u to the n is equal to d. So we cannot take that 5 out. Instead, we're going to take the 4th root right away. X plus 5 is equal to, because it's even, don't forget your plus or minus. Plus or minus is going to be important on your test because if you only do one of them, you'll only get half of the answers, only one of the 2 answers. So you'll only get half credit for an entire problem. This is on our list. This is equal to plus or minus 2. So interestingly, sometimes people don't like this problem because it's left with that square root of 21 in there. But actually, that's a little easier because you don't have to simplify that. On this one, I do expect you to simplify. So this is x, you can't leave it minus 5 plus or minus 2. Those are regular numbers. You should be able to do them. So negative 5 plus 2 is negative 3, and negative 5 minus 2 is negative 7. So make sure that you get both answers. Do not leave it as negative 5 plus or minus the square 2. I will take off for that. Again, you cannot add 2 to both sides. That negative 2 is stuck in there. So I'm going to cube root both sides. And a cube is an odd number. So I can have the cube root of negative 14. X minus 2 is equal to the cube root of negative 14. And then x is equal to 2 plus the cube root of negative 14. However, no one's going to write it like this. Instead, people are going to take the negative out. It's a little bit tidier, nicer to write. And here's why you can do that. Think about things that are perfect cubes. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. I don't know what the cube root of 14 is as an actual number because it's going to be a decimal of some kind. But I do know that if I could figure it out, it would be negative that number. So instead of leaving the negative underneath, it's tidier to bring the negative out because that will still work. So you could think of this as negative cube root of 27. And then that goes to negative 3. Hopefully that makes sense. Okay, let's do some word problems. Number 1 says a hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation, so the annual depreciation rate, R, in decimal form, is given by this formula. In the formula, N is the useful life of the item, S is the salvage value, which means the value that you get at the end, and C is the original cost. What annual depreciation rate did the hospital use? So we're trying to find R, which means everything else can be filled in. R is equal to 1 minus S over C to the 1 over N. R is equal to 1 minus salvage value, 8,000, over C, the original cost, 50,000, to the 1 over N is the useful life, which they think to be 10 years. So this is all about, can you correctly plug this into your calculator? So a lot of times when people do hard things like this on their calculator, they do it in pieces. But I really have to stress, it's nice to have it look exactly like you think it's going to look. So use your alpha button. Use the alpha F1 and make that fraction. 8,000 over. In this way, when you get it to look exactly like what you want it to look like, you can feel very confident in the answer. You could even use the fraction button again to make 1/10. Oops. 1/10. So now it looks just like our problem on our piece of paper instead of doing it in pieces. So they did say that the R value would come out into a decimal, 0.167, although as a percentage, that would be 16.7%. Number 2, find the radius of a right circular cylinder with a height equal to 9 and a volume equal to 1,332 cubic centimeters. So a right circular cylinder, so probably you know what a cylinder is. Circular, as you can see, and right just means that it's standing upright versus something like this, which is a cylinder but is leaning. So right means right angle or 90 degrees. So the formula for that, for the volume, is pi r squared, which is the area of the base, and then times height. Because if you take a base, think of it like a round coaster, and you keep adding coasters until you get to the height that you want, you'd be multiplying that one base, that 1 pi r squared, times the height, and that would give you a solid volume. Now, any formulas that I give you in class, you would be wise to add to your appendix, but also you will need to have them memorized. So in case you see something like this on a quiz, you need to know that formula, which is why I showed you how it's created, because it makes it easier to memorize. So volume is equal to pi r squared h. They told you that the volume is 1,332, and they told you that the height is 9. So I'm going to divide both sides by 9, and that gives me 148 is equal to pi r squared. 148 over pi is equal to r squared. And then you can square root both sides. Now, normally, when you take the square root, when you draw a square root, it's your job to put in the plus or the minus. But it's also your job to recognize that when it's a word problem, it's not going to be plus or minus, that the radius is always going to be a positive value. So you can go ahead and type that into your calculator. I'm typing it into mine, and I get R is equal to 6.864. It's in centimeters because it's a linear measure. So your measure, if you can measure it with a ruler just in one direction, then you know that it's just centimeters, not centimeters squared or centimeters cubed like volume is. All right, let's do number 3. A weir is a dam that is built across a river to regulate the flow of water. The flow rate Q can be calculated using this formula. Determine the flow rate of a weir with a spillway that is 20 feet long and has a water depth of 5 feet. So I'll try and draw this for you. It's not going to be perfect, but let's just say that you have this river. And of course, you don't really see it this way because if you're standing up here on the bank of the river, you don't really see how deep it goes down. You just see, where the water is. But there's some kind of a spillway that has a certain depth, h, and a certain length of the bottom of the spillway. Determine the flow rate of the weir, so Q, 3.367, there's an L in there, that's not a 1, L, h to the 3 halves. So 3.367, L is equal to 20 feet long, and water depth of 5 to the 3 halves. So while it looked like a complicated problem, a lot of times some things are just plugging things into the formula. You can go ahead and do that on your calculator, and the answer is 752.884. And this is going to be cubic feet. They gave that to you, cubic feet per second. All right, that's it. That is the end of section 5.1. I hope you have a great day.